This episode is brought to you by Amazon. Sometimes the most painful part of getting sick is the getting better part. Waiting on hold for an appointment, sitting in crowded waiting rooms, standing in line at the pharmacy, that's painful. Amazon One Medical and Amazon Pharmacy remove those painful parts of getting better with things like 24/7 virtual visits and prescriptions delivered to your door. Thanks to Amazon Pharmacy and Amazon One Medical, healthcare just got less painful.
You're listening to the Reversing Climate Change podcast by the team at Nori, the carbon removal marketplace. This is a show about the innovators and entrepreneurs developing solutions to climate change.
Hello and welcome to the Reversing Climate Change podcast with Nori. I'm Ross Kenyon. I'm the creative editor at Nori's carbon removal marketplace. I cannot believe that this is happening. David Addison, a climate and sustainability practitioner based in the UK and a long-term friend and advisor to Nori. How do we finally get you on the show, David? I'm so happy you're here. I think you're the biggest fan.
Good evening, Ross. Long time listener, first time co-host. That's the
first time co-host.
That's the line, isn't it?
First of many, I hope. Yeah.
Very grateful to be here and very excited to talk to our guest today.
Me too. I think you're the biggest influence on me to think more about planetary science and astronomy. You turned me on to David Grinspoon in the beginning, and he's been a huge influence on how I see things and how I think. I wish that perspective was more present in climate change discussions broadly. And following up on this, we had the opportunity to speak with Heino Falcke, professor of astroparticle physics and radio astronomy at Radboud University. Very well known as a black hole photographer. That's something that we're going to talk about today. And author of the book, Light in the Darkness, Black Holes, the Universe, and Us. Welcome to the show, Heino.
Hello. Great to be here and to meet you.
We're grateful to have you here too. Well, David, I wanted to give you first crack at this. If you want to introduce a little bit about the book, what stood out to you, and frame this conversation a little bit.
Yeah, sure. And for your benefit, Heino, for a bit of context, some of the latest episodes of Reversing Climate Change have covered everything from the need to have better conversations, better dialogues across political divides, the relationship between extreme weather and conflicts, how you can make non-fungible tokens or NFTs wrapped up into ways of taking carbon out the air as a way of moving this emergent area forward amongst many. And when Ross messaged me about a year ago with the story of this book, which is just, it's awesome, by the way. I loved it. I read it then, loved it. Did the audiobook again recently, can highly recommend it. None of the listeners rather can see this, but I'm waving the book at Ross and Heino on the screen, sure, just for your benefit. And I thought, this is pretty out there, if you'll forgive the expression, in terms of, the relationship of black holes, or what's the term in the book, like fully gravitationally collapsed objects to climate change, to the carbon cycle, to these very pressing and very immediate issues of our time. And nonetheless, the more I read, the more I just thought, humbly, it was a really interesting story and maybe had some interesting perspectives, if nothing else. So I thought it was just worth having a conversation with yourself. And if it goes wrong, for the record, it's entirely my fault.
You don't have to take the lion's share out front. It's very, very humble.
It was
very British, I think. Yeah, we're happy to have you, Heino. Well, the view from space and all that, super important. Why don't we start there? We talk so much about carbon. I was wondering, Heino, if you could introduce for us, where exactly does the element carbon come from? How are these molecules made, since they have such an influence on seemingly everything that we touch and do?
It's a very interesting question, because in the beginning of the universe, when after the Big Bang and particles were created, it was mainly filled with hydrogen and helium, and carbon wasn't around, at least not in very big quantities. And so what happened was this amazing cycle of life, you can say, in the universe, where the hydrogen was collapsing into galaxies and stars, and then the first stars were lighting up, and nuclear fusion was happening in the center of these stars, and hydrogen and helium were turned into other elements, carbon, oxygen, nitrogen, and if the star was very big, in the end it was even turned into iron. And so the elements were cooked in the centers of stars. And then the elements exploded. The stars exploded. The elements, of course, with them. And they were, shot out into interstellar space, and it was cooling off and turning into dust, essentially. And you had, all kinds of molecules forming, and they're going, flowing through empty space. And then the dust was pulling together again under the influence of gravity, which is, interesting. Gravity is a creative force of the universe. Without gravity, nothing would be. Why is this? It's the weakest of all forces, but it only knows one direction. And so if everything pulls in one direction, even the weakest force can actually overcome everything else. And that's what's happening in the universe. And that's why gravity creates. It makes new stars and new planets and so forth. And so these dust clouds, pull together, and a new star emerges, which now has more elements. And then, some of the dust is left and going around in a disk-like configuration, like Saturn's ring around Saturn. And in these rings around the new star, a planet will form. And one of these planets will be our Earth. Once again, I have a lot of hydrogen and helium in there, in the atmosphere, but it will evaporate, in the early phase of the Earth. And then CO2 will actually emerge out of the volcanic activities of the Earth. And so you have an enormous climate revolution in the early phase of the Earth. And the Earth will become warmer than it should be, based on just the radiation from the sun. It was good at the time. It was good. It kept us warm. And then life emerges, methane comes, and it gets even worse, or even better actually, with the climate effect, the greenhouse effect. And then you have the first cyano algae coming up, and they're producing oxygen. They're turning this into oxygen. And then we have the atmosphere we can breathe. So it's a long process from the early phase of the universe. Out of the Big Bang, you create something crazy as particles in the first place. Right? They didn't exist in the beginning of the universe.
Right.
And then you turn these, hydrogen and helium into new atoms, and these atoms turn into molecules, and they form planets, and then these planets forms atmospheres and life, and in the end, it's all in us. And we're talking about the universe again. So it's, all the carbon and oxygen in us, and it's now thinking about where it came from.
Anything deep time related always makes me feel a little bit stupid or just small, or it's hard to think at those scales. And I think that's part of why being a human is so challenging, because we can't see very far outside of ourselves or out of maybe 1,000 years or a couple hundred years or even our own lifetime. David, you have more experience at this than I do. Is it any easier for you? Or is it also just like, if he had swapped in different elements there, different timescales, I'd have no way of knowing. Like,
no,
sounds plausible.
I think, for the record, Heino, I think your science fundamentals is better than humbly my astrophysics fundamentals for sure, despite being a fan of sometimes looking at and exploring that stuff in my own time. Is it true as well? And apologies if this is a question more for some colleagues who maybe focus on stellar evolution, but is it right that it actually takes a really long time relatively to get to the element of carbon in a star compared to, say, some of the heavier elements later on? I think I read somewhere that it could be millions of years to get from things like hydrogen and helium to carbon. Sorry.
It can take billions of years, of course, in the end, because you first start with fully hydrogen that you have to turn into helium, and then the carbon, the production of carbon takes place even later, and it sometimes takes 2 generations of stars. So in the end, it takes those billions of years for these processes to play out. Of course, in the evolution of stars, the heavier elements are produced faster and faster towards the end. And you have some sort of onion shells. It's sort of a star consists of different onions of different elements, burning different stages of the nuclear evolution of the elements in stars and the nuclear fusion. And that happens on different timescales. And the last phases can be very, very fast. But the entire process, in the end, that something comes here to a planet, really takes billions of years.
Right. So, in summary, as I think what my son once said, less of a big bag and more of a big ta-da at the beginning, and then eventually simple molecules, more complex molecules, generations, maybe several generations of stars, supernova, collapses, net dust clouds, solar systems, climates form, living processes form, and here we are. It's
an almost an ecosystem out there. It's an entire ecosystem out there. This entire universe is to some degree an ecosystem that allows us to live. And, it's necessary. We need this big machinery to, have this little bit of life here on this planet.
What led you on this path, Heino? I know your work focuses so much on black holes. How did you become interested in such a thing?
Well, I was always interested by fundamental questions. And I was a curious kid. Was always ask questions and why is this? And I didn't stop. It's where the adults would say, come on, shut up. And I remember lying awake as a kid and thinking about what the universe and heaven and what's out there, and is this infinite or is it finite? Or if it's finite, what's behind it? And what is then behind this thing? And if that's finite, what's behind that? And you never came to a conclusion or an answer. Is there a God? Is there nothing, or is there an infinite? And so I was asking these kind of questions, and now I was thinking about what to do as a student. Do you want to do philosophy, theology, physics? I was a nerd, to be honest, so it became physics. But I want to do something that's to the as fundamental as possible. So particle physics, perhaps. But then I realized that gravity is, the last big mystery in physics. We understand all the other forces, not everything perhaps, but we understand them in a big model. But gravity wasn't really understood. It was resisting assimilation into the big model of particle physics. It stood really apart, and it's still the case that general relativity, the theory of gravity, doesn't go together with quantum physics. And these are the big theories that govern everything in the universe. Quantum physics, the matter and the light, the little things. Well, general relativity, governs the big space, time, the entire universe. That's what it describes. And all that comes from a little Big Bang at the beginning, or even before a Big Bang, from something that is a quantum-like object. And so it had to be together. You have to think it together. But we don't understand how that works. So that's what I wanted to understand. I realized I was probably a bit too not smart enough to really understand that all. So I thought, let's try to stay close to black holes, because that's where gravity is the strongest, and that's where maybe the new physics may show up at some point. And that's how I was led in that direction. I was drawn into black holes by their really attraction, by their fundamental attraction.
Nice. Yeah. I can neither confirm nor deny that we had what attracted you to black holes as a pre-prepared question. So, yes, noted. On that, maybe just one question, reflecting on the listeners to this podcast and where they are in their own journeys. Did you always believe that you could become professor, working with other awesome folks around the world on envelope pushing projects? Did you always have that belief that you could, or were there times where you really thought, am I on the right path? Am I good enough for this? Am I doing the right thing? If that makes sense.
Both. I wanted to do this. That was my passion. And when I started physics, the professor, we were 300 students in the big lecture hall. And the professor told us, well, by Christmas, there was a few months, you look left and right. So of the three of you, one will be gone after a few months. And at the end of the semester, only one will be left of the three. That was not very encouraging. And then getting even a professorship was, it was very hard. Certainly at the time, there were not many positions. I just wanted to do it. And I was convinced I was going to do something fundamental, and I wanted to do it. And I was never satisfied with just doing little thing. I always had sort of the big picture in my back of my mind. That's where I want to go. I want to understand black holes. I want to, see black holes. I want to understand the physics near black holes. Yeah, that it worked out in the end is also luck to some degree. You have to be honest. You can be as smart as you like. And I'm not, not as smart as I would like to be, but you have to be also at the right place at the right moment, and also seize the opportunity. When I started my PhD, I was working on something related to black holes, but then, some new discoveries were made by a guy, Reinhard Genzel, who saw some stars in the center of the Milky Way. 2 years ago, he got a Nobel Prize for that. That was just a very early phase of these observations. And I thought, oh, that's amazing. What's happening there? And because you can use those stars to measure the mass of the black hole very precisely. I completely jumped from one topic to the other. And I said, that's what I want to do. I want to be there in the center of the Milky Way, understand if there's a black hole and understand what it's doing. And it's interesting. I don't know what I'm going to do, but, I'll do something there. And that worked out well. I'm still, my professor at the time said, oh, yeah, let's do this. I mean, let's make this model here. It'll take us 2 weeks. I'm still working on it today.
Right.
20 years,
sure.
30 years later.
Yeah. Interesting.
Some of your most prestigious or well-known work is actually taking a photograph of a black hole. I imagine a listener has no idea how such a thing is even possible. Maybe we should walk them through that.
Well, I think most my colleagues would have thought that's impossible in their lifetimes. And when I started, I thought it was impossible. But, working on this black hole, particularly in the center of the Milky Way, but also others, two things. One was the theoretical realization that the black holes are dark, right? How do you see a black hole on a dark background? It's impossible to see. But if you shine light at a hole, then the light will disappear in the hole, but you'll see the light surrounding it, and that's what you have with black holes. So you if you shine light at them, you see a darkness, and so the signature of black holes is actually that darkness where light disappears, because that's what black holes do. Everything goes in but never gets out, not even light, and because they have such a strong gravitational attraction. And I realized that in the central Milky Way, these black holes would be radiated by radio emission from all directions. And I was working at an institute where they were actually developing techniques to make very high resolution images. But it turned out you needed a telescope the size of the Earth at the highest frequencies, produce the very highest resolution ever done in astronomy. But it would be possible. At the time, it wasn't possible. It was clear at some point that would be possible. And if we could do this, then we could see that black hole. We would not see the black hole itself. We would see its darkness, its shadow, as we called it later. So I worked this out. We made a prediction, published that in 2000, said we can see the shadow of a black hole. And we need to build this worldwide radio telescope array, combine telescopes around the world. We need the perspective from all the continents, essentially. Look under slightly different angles. And if you put that together, you can actually recreate an image of a telescope that would be the size of the Earth. And that's what we did. In 2017, we did this experiment. Yes, I'm skipping a lot of the story here. It's in the book. And in 2019, we published the first image, and I had the honor to present this in a big press conference and to show, this is the first image of a black hole. And that was to me, a momentous moment, because you turn something that was a theoretical fantasy sci-fi thing into a reality that you can see. You can look at it. And I just of course I had seen it before, and I was at this press conference. I'd seen it before, but just sharing it with the world. I think in the book I write this one sentence. We took the image with the world, we gave it back to the world, and the world embraced it in a way I'd never expected it. It became a global sensation. There was like 4.5 billion people saw that image. It was sort of everywhere at the time in 2019. And recently we published another one which didn't get quite as much attention, but still was a big thing. And looking at sort of the end of space and time was suddenly possible, and seeing the darkness of the event horizon.
Is it right that to kind of put the scales in perspective, I think you write in the book that imaging the first black hole, which is the massive black hole, 6 billion with a B plus 6 billion times the mass of the sun at the middle of M87, just an enormous, not that our galaxy isn't enormous, but an even more enormous galaxy, 55 million light years away. Is that correct? Is that the right scale? Oh, yes, thank you. Yeah. Oh, no, my old A-level physics teacher, if they were listening to this, would be like, oh, well, he took something in, so that's good. But anyway, I digress. So is it the equivalent of basically, I think you say, taking a photo of a mustard seed in New York when your camera
from Europe,
is in Europe?
Exactly. Yeah.
Mind-boggling scale. Sorry.
You could read, with such a telescope, you could read the New York Times or the Washington Post, whatever, in New York from Europe, or the other way around. We also have good newspapers in Europe, so which you maybe should be trying to read.
Right. Again, given the theme of this podcast, 55 million years ago was a pretty interesting time for Earth. The climate was much warmer, CO2 was much higher. A lot of as I understand it, and people should go and listen to episodes such as those with Peter Brannan for a more accurate description of this whole realm. But I'm pretty sure that a lot of the modern species of mammal were really starting to show up in the fossil record from around that time. Primates, whales and dolphins, known as cetaceans, all that sort of stuff was really starting to get going on Earth, just as the radio waves that would have been leaving the M87 supermassive black hole. Yeah, well, obviously, I know that when you get into general relativity, that's maybe not strictly true in terms of how time does or does not go against the universe. But indulge me as an Earth scientist.
Yeah. It's amazing. Yeah, this is sort of, we're looking back at the age of the dinosaurs, so to speak, when we're looking at this object, and that's close, actually. It's on cosmic scales. This is actually our neighborhood.
This might be a facile question. It's a little bit freshman hanging out in the dorm room. A hazy dorm room, one might even say. How could a black hole exist? There's no way to ask it. Surely we're going to end up in theology here, I think. But why?
No. Why they exist?
Why?
They're natural. They're a natural consequence of gravity. As gravity only has one direction. I thought, it's actually they're the consequence of the fact that anything exists, because we only exist because of gravity. That sort of is a creative force, and sometimes it can sort of be too much, and then everything collapses and keeps collapsing forever because there's no force that can stop it. If there are just so many particles pulling in the same direction, there's nothing in the universe that can stop it from forming and from collapsing, and then a black hole will form because it was sort of all the matter is compressed into a point. So in the end, it's like, it's always good and bad. There's, if there's light, there's shadow. If there's good, there's bad. And I'm not going to say that black holes are bad, actually, by any means, but unless you fall into them, so then they're actually pretty annoying. You won't get out. But that's the price you pay for the fact that anything exists at all in this universe that resembles anything reasonable, like stars, planets. We all hold together by gravity. We were brought together by gravity.
A more general way of asking this is, again, very dorm roomy, but no other way to ask it. Why does the universe have physical rules? Why is there such a thing?
Dang, we're going meta.
Yes, that's and why can we understand them? I mean, they're simple enough. I mean, you may not say they're simple if you've had to take some courses in physics, but in the end, they're simple enough that the basic principles of this universe we can understand. And it's quite interesting. Of course, I have a little bit of also theology background. If you look sort of at the Bible, then the first thing that was created was light. Yeah. But before that, it's God, and God spoke, or God said, "Let there be light." So there's a word, in the beginning was a word. And also in every scientific creation story that we tell, you always start with a set of rules. And they turn something into what we see today. Sometimes nothing. Well, you never start with nothing, actually, in modern, in scientific stories. So, where does this word come from? Where do the laws come from? And why is it that we can understand them even with our little brains? That's one of the big mysteries and challenges. And I find it still amazing. And I'm thankful for it. We could live in a universe that completely doesn't make any sense. Some people say we do, but to a physicist, I think, there is some sense and order in this universe.
I was only briefly, I was at an event in the UK a few weeks ago with a bunch of scientists, people from universities, on specifically this area of taking carbon and other greenhouse gases, or mainly carbon dioxide, out of the atmosphere. And I think the most common term throughout the whole day was 3 words: real world complexity. And just every scientist who got up and was talking through a particular approach, however ecological or industrial or other ways of classifying them, it was just actually very illuminating and heartening to see a bunch of folks really trying to grapple with that complexity, coming at it with that humility you have to, I assume, as a scientist, to really try and understand all these physical phenomena and really try and make sense of it. It was just a very interesting day.
That's a very important point that you make. The basic laws may sound simple. The first word was simple, but it created enormous complexity. And actually also an exciting universe, and also a universe that gives a lot of room for new things to develop, and also prevents us from predicting everything in the end. Science is about predictability, and we can predict things if they are simple and clear. But how a complex system evolves, it's almost fundamentally impossible to really predict in great detail. There's again in the book, there's actually a planet, an asteroid named after me, and you can predict how this goes around the sun for a while. But actually, it will interact with all the other asteroids gravitationally and the planets.
Right.
And so, over long time scales, it's completely unpredictable where Heino Falcke will be in the next couple of million years. And
right.
So, I was saying I was praying that it would never hit New York, because, I would be really sorry to hear in the news, Heino Falcke destroyed New York. But it's something you just can't tell. You just can't tell. It could happen. That's very unlikely to happen, but so complex systems are inherently unpredictable. So you have to try different things, different approaches, and you have to make assumptions. And that's where I think we have to understand what science is. It gives us certain rules, certain directions. We still have to make choices, and we never have absolute certainty, even when we do science. I mean, there are, some cases that are, easier to sometimes it's easy to predict what's going to happen. Like if we don't do anything, like with carbon, for example, greenhouse effect will just, keep going. Sure. I think that's very solid. But, if, as you say, if you fiddle with it, what effect will these have? It's an interesting question.
Yeah, sure. And maybe related to that, I think without going too deep on the carbon side, most areas of both cutting emissions in the first place, which is still almost cliched to say at this point, but almost still necessary to emphasize. You've got a lot of proven scaled things. You've got renewable energy. You've got energy efficiency. You've got more sustainable ways of managing land. And there's a huge amount of complexity and science and research that's gone into each of those. Broadly speaking, many people out there today advocating for taking carbon out of the air will talk about how a lot of these solutions have to go on the same sort of journey to grapple with the fundamental science and engineer that into the real world. If you're dealing with hardware, figure out how these complex natural systems, from soils to oceans to forests and other things, can restore their own carbon balances and carbon budgets and carbon stocks as well. Maybe one question for you, Heino, is... Plus,
it's a social question as well.
Well, no, quite, yeah.
Don't forget that.
Yeah. And so,
if people become poor, start revolting, they don't get, they're not fed anymore or whatever. I mean, it's more than just a biology. It's a very, very complex issue. That's why it's not just science in the end. Unfortunately,
Right.
that would make it easier. So
No, for sure. There's a big. I know Ross knows this as well, and many of the Nori team do. And I think many of the past guests you've had on the podcast have really spoken to how this whole area of sort of redefining and restoring our relationship with the climate has to go hand in hand with a bunch of other important areas of sustainability, of justice, of equality, of inclusion, and not to kind of segue too much, but as far as the EHT project went, I just humbly thought it was really interesting how, I think you mentioned it was close to 350 different scientists around the world collaborating in a bunch of different elements of it. I think one line in the book was, the sociology can be harder than the physics. And
yes.
I know, obviously, helping have every, diverse part of the world with all its local complexity go on this journey and seeing and imagining all the different ways that many millions and ultimately billions of human beings would collaborate is maybe not kind of directly translatable from 350 highly qualified astrophysicists working together to image a black hole. But it seemed like reading the book, just those principles of getting projects going, turning curiosity into discovery, how you stay rigorous, how you question yourselves, how you collaborate whilst also competing, how you even help people change perspectives. Would you have any particular advice or perspectives based on your own journey imaging black holes for people going on their own areas of scientific discovery in other fields?
To me, that was a very fascinating experience. The sociological development as well. The Event Horizon Telescope, the EHT, you mentioned it. It was a vision in the beginning of a few, but it became sort of bigger and bigger, and then you had sort of people from different continents. They had different telescopes, different backgrounds, sometimes theorists and observers and experimentalists and data analysts. And they come together and to have this one goal, to make an image of a black hole. You need them all. But they have different ways of thinking about it, different ways of talking. And it went very quick, actually. Even at the time when we did our first experiment, we hadn't even settled down all the rules of the engagement. And then you see how sort of, I think it's like even in medieval state nation building, right? Rules emerge and procedures emerge, but it's all hard fought. It costs a lot of effort to talking to each other. And there were a lot of anger as well, disappointment and problems along the way. I don't even describe them all. You could write yet another book about it. But it was certainly the goal that kept us together in the first place. And indeed, some principles that are important. Certain principles, for example, that we wanted to do everything multiple times to check what we're doing. So not just rely on one source, but have multiple teams doing the same thing. And that leads to an interesting competitive collaboration attitude. Because, within the collaboration, it was clear we would come with one common result. But everyone was competing to having the better methods, and their methods were checking each other. And they were and was creating it was producing a lot of creativity as well by putting out this challenge and have teams to work and compete a little bit. But it's going to be one framework. Everything will actually be, in the end, almost everything we used. But you had like 400 pages published. It was just all the methods and all the checks that were done. Every pass we took was an important one. And I think the same applies to other global challenges, that we need to explore these different challenges, but we need to find a framework where those different ideas can lead towards this common goal. And of course, we have to agree on this common vision. And that's still a problem, in the world, that we haven't embraced this as a common positive vision. Many people see this as a threat, right? So nobody in our collaboration thought that, make an image would be dangerous or bad, or would, everybody understood this was a big thing. And you believed it was possible. With climate change, there's still, many people who, challenge it, even are afraid of it, doing something about it, are afraid of it. So it's never only a technological question. It's always also a sociological question. And honestly, we could have failed easily. There were many places many times where the collaboration could have exploded, where things could have gone wrong, we could have taken the wrong turn, and it was a lot of effort and talking. And again, that vision to, we have to all together get to the finishing line, and we don't want to leave people behind in the end. So that was also, maybe some people felt left behind to some degree because they weren't equally recognized as some others. But, in the end, I think everything, contributed to the bigger goal.
I know I have to ask you, because you've mentioned theology a number of times, and you also had a good Christian dog whistle. I'm mentioning a mustard seed, because you could have answered poppy seed, but everyone knows that mustard seed, let's just say the reference didn't fall on stony ground over here. I think it's safe to say. But people would not associate these two things, Christianity or really any religious belief potentially, with astronomy. How could one justify these two things? There's cosmological interventions of God through Jesus. I don't think people expect this of scientists. What do you think they're missing?
Well, it's I have a Christian background. And I'm even an ordained lay minister, so I preach occasionally, and I think it's a very good other leg to stand on, to see what people feel about, what they think about, to talk about the spiritual needs as well. But it also makes you think about, of course, of the universe. And yes, I do like to use then certain biblical, terms, because the mustard seed is also a symbol of hope. Yeah, it's something bigger can grow out of this. That's why I like to talk about the mustard seed that you see, because you see something small and that could turn into something really big, if scientifically, but also maybe beyond this. So there's some symbolic nature to this indeed. But yeah, I want to contradict what you're saying, that people see that as a contradiction. In fact, throughout most of history, that really went together. A lot of the science that we see today came from believing scientists. Look at Kepler, for example, who revolutionized our worldview and formulated the motion of the planets around the sun, which led to the law of gravity by Newton. By the way, another theologian. And he was fascinated by the beauty of the universe, and he ended with a big prayer at the end of his book. We don't do this in science articles anymore, but they had a deep sense of something bigger out there. And I think that sense is still there. If you look at this mighty universe, it's never just a technological view. It's always a little bit a spiritual view as well. What's out there and what's behind, and where do we come from? And that question, I think science will never answer. Where do these laws of nature come from? Who spoke the first word? Was it someone, or was it something? Were they pre-existing, or, where does it come from? You have to start in science from a certain set of rules, and you cannot ask anymore where they come from. Phase gives you a place, and you connect it then, and that's what religions do. They connect that sort of first cause, those deep metaphysical questions, with sort of spiritual needs of today. And I think people do need that, because science shouldn't be used sort of for spiritual, things in a way, right? It shouldn't solve all our emotional, spiritual needs. And science is not the place to ask why questions. Why does it happen? What is my purpose? These are questions you don't ask in science, and you shouldn't. You shouldn't force science to do this. I sometimes see that's happening. But so again, I think we need to stand on two legs if we want to develop this world further. We need very excellent, outstanding, critical, skeptical science, but we also need very healthy spiritual minds and souls and bodies and societies in a way. Criticizing some churches, I think, they could learn a bit of scientific methods. Also be a bit more critical of themselves sometimes. It's science, knows certain truths, but only within a certain limit, and nobody knows it all. And it was recently in another interview, and I was remembering when I was in the US like 20 years ago. There was a Bible answer man, I think that was even his name, And you could ask every question. He would look into the Bible. He could answer every question. Is there life out in the universe? Whatever. You could ask whatever. And he knew everything, and he knew it exactly right. He knew everything. Oh gosh, how do you do this? The scientists know a little thing that he or she knows very well. But about the rest, we have to talk to experts. How can one person claim even he or she knows everything? So I think a little bit more humbleness among churches would also help us a lot in that discussion, and more conversation between the two.
Well, no, sure, yeah. Well, in that regard, have either of you watched? I can't remember if I've enthusiastically promoted this to you and other Nori nauts yet, Ross. But have you watched the film Contact, the 1997 adaptation of Carl Sagan's book with Jodie Foster and Matthew McConaughey and a wonderful ensemble cast about finding a signal from and so on and building a craft to go there? Because the film version, watched it. I know other people in this space have watched it and loved it as well. I remember watching it and enjoying it as a kid. I watched it as an adult and just absolutely loved the interplay between science and faith that happens between Jodie Foster and Matthew McConaughey's characters in that film. I just thought it's a really lovely story.
Yeah, no, I saw that, and I think that it was an interesting twist in the end. The clear science wasn't believed anymore because I don't want to give away the plot entirely, but
the movie's been out for several decades. I think you're safe if you'd like to.
yeah.
Spoiler warning.
Yeah. Human societies and humans are just more complex indeed, and I think ignoring the spiritual needs that we have, and also the strengths. There's the strengths it's we always in science we try to get rid of any spiritual thinking, and that's good, right? But for solving problems in the complex world of humans, you cannot think without the spiritual world of your inside and what you believe. What you believe about the beginning affects how you treat others and affects how you think about the future as well. And I think what we also need, next to knowledge, which science gives you, we also need hope. Hope, love, and faith. These are the three things that we also need. And I think science can neither give us anything. It gives us knowledge.
When I was younger, secular humanism, I had many progressive peers that, and I think even myself at some point, were very, very bullish on it as a replacement for religion. Religion was this corrupt arena that humans had in the past been misled by, and now as a species, we were moving past. But a lot of my friends who are of that sort of progressive continuum, I think as they've aged, have gotten into weirder, or maybe I should say newer types of religious experience. Many of them are into tarot or astrology or things that are coming back now that are new age, or some pagan beliefs too. So I think a lot of people are realizing that placing so much on science and secular humanism maybe wasn't the thickest of places to build a foundation, and that actually they needed something a bit more, and they've been looking. I don't know that everyone always experiences that as a conscious phenomenon. I think for a lot of people it's subconscious. And I don't know if you've experienced a lot of that, Heino, in your circles, or David, but I've seen that.
Yeah, and as you recognize certain developments, or another example that I see in scientific circles is that people start thinking about, is this world real actually? Are we living in a big computer simulation? Which is you hear that people actually, scientists actually trying to test that hypothesis. Are we living in a computer simulation? Because the world is too perfect in a way that it works actually. But then I was thinking, isn't that idea that we are just, everything we see here is not real, and we are just we're set here in a computer simulation that was started at some point by someone. Isn't that a very fundamentalist way of looking at it? So like in a 7-day creation, idea, someone placed everything there and then it ran, you now think the entire universe is a computer simulation where some programmer put it there. What's the difference there? I don't believe this. And I'm neither a creationist that believes in the 7-day creation, nor do I do believe in the computer simulation. But it shows that people start, getting all kinds of ideas. And that to me is actually also a religious idea almost, but coming in the form of tech, yeah. Or thinking about Elon Musk, who is sort of a messiah for technology fans. And I say this, I probably get hate mails, and I do if I sometimes say this on Twitter or something negative about Elon Musk. Yeah, like a new prophet of the technology world, and of course, like all these new prophets, and I miss the English word for it, Heilsbringer in German. You have to be very careful and mindful, and it can be dangerous. So I think that's why having organized religion is. I mean, I understand everything you say about corrupt churches and so forth. I mean, they do exist, and people are being misled. But we also need to keep our churches and communities alive and well, and doing a proper job, and also being critical about themselves. And starting something completely from scratch, I think, will not be better.
I'm imagining now, Ross and Heino, a sort of proverbial pipeline of researchers trying to work out whether or not the universe is a simulation, then going into detailed soil carbon simulation or ecosystem biodynamic modeling, or something for a real challenge rather than those kind of areas. And I think I think I looked this up on Wikipedia. More than 80% of human beings in the world subscribe to one of the major faiths: Buddhism, Christianity, Judaism, Islam, Hinduism, or some form of, I think, other folk religion, for want of a better description. And to your point earlier on, Heino, if issues like climate affect everyone and ultimately, yes, require leadership from people in positions of power and influence, but ultimately need human beings around the world to reimagine and redefine how they interact with the carbon cycle and the climate system fundamentally, it just seems to me that maybe there are more ways of bridging gaps between the scientific and the spiritual world. And I humbly thought, not to wave the book again, but Light in the Darkness was just a really nice example of going through a journey that attempts to do that. So thank you for writing it. Thank you for getting an audio book out as well, so I could listen to it whilst cleaning the bathroom and doing other chores. And
don't tell him that, David.
A mind-opening experience at the same time with ecological bathroom cleaner, I urgently point out. But yeah, just thank you so much. Thank you so much for writing it. Ross, have you got any further questions? I've got a couple of kind of closing ones. Have you got any?
Mostly just want to know where people can follow your work and keep up with what you're doing for the future, Heino.
Well, I'm on Twitter, H Falcke, HFALCKE. You can also find me on Instagram and Facebook if you want. There's a webpage, lightinthedarkness.org or heinofalcke.org even. So just Google me, Heino Falcke. I'll be, maybe I'm going to write another book, something in that direction we're just discussing. But it'll take me a little while to do that.
We'll be glad to have you back on when the time comes. David, is there anything you'd like to add, or should I start signing off?
Oh, I might. I highlighted a quote from the book. I don't know if it's massively corny, which is also the theme of a joke I have about industrial agriculture, by the way, but I won't go in that direction. I could read a brief quote from the book. So in the book you write, Heino, we humans are just specks of dust on a slightly bigger speck of dust in the immeasurable vastness of space. We can't cause stars to explode. We don't set the wheels of galaxies spinning. And it is not we who span the vault of heaven above us. But we can marvel at the universe and ask questions about it. We can have faith, hope, and love in this world. And this makes us stardust of a very special kind.
Yeah, I think that's, yeah. And in all this discussion about this universe, this Earth, you sometimes get the feeling, and sometimes hear the statements, the humans are the virus. Realize how bad we are for this planet, and that's very true. But we should not forget how special we are as humans, and that we can change things. But I think we can only change things if we want it and if we love what we do, if we love ourselves, and if we love that planet. And so that's part of this process that we have to go through. And that's, again, sort of a spiritual challenge. That's also important for religions, to actually embrace creation, embrace nature more. There are lots of statements also in the Bible that sort of, one day tells it to the other, and, that you listen to nature. And so we need to get a different perspective of ourselves again and of nature, that we're part of it. We are physics, we are biology, but we also art and songs and stories, and all that makes us. And that makes us very special. And I think we have a place to live on this planet. Some people doubt that even. Yeah. I think we have a place to play, and we can do marvelous things, but we have to find a way to do this in a sustainable way that, gives us that freedom and that ability for the many generations to come in the future. Together with nature, not against it. Together with technology, together with science, not against it. Together with religion and spirituality, and not against it.
Amen. Amen.
That's a beautiful point to conclude on. Heino, thank you so much for being with us.
Well, it was great. Pleasure to talk to you. It's always, it's so nice to be, asked different kinds of questions. And so you're drawn out of your daily routine and suddenly think about something much, much bigger. And that's what I love doing. And thank you for giving that opportunity.
That's a high compliment, one that I always am glad to receive. And thank you, David. You're no longer a podcasting virgin. You're now initiated into the world of podcasters. Congratulations. I can edit that if you don't want me to call you that on the air.
No. Call me what you like. I've been called worse. And feedback welcome. Please write to hello@nori.com for your commentary and constructive criticism. Is that still the email?
I forget to do that now. I'll just do the normal sign off. But yeah, you can always write to hello@nori.com if you have comments or feedback of any kind. Thanks so much for listening. If you like the show, please tell a friend. Give us a great rating and review on iTunes, which is now Apple Podcasts or Spotify. Thanks so much for listening, and have a lovely day. Thank you so much for listening. If you could please subscribe and give us a great rating and review on Apple Podcasts or a rating on Spotify, that'd be much appreciated. It helps us get our content out to more people. You can sign up for our newsletter at nori.com, follow us on social media, and we will catch you next time.